In this part of the lab, we want to find the index of refraction of this prism by using the principle of least deviation. So here we have the incident light rays, and then they go through the lens, and then they get refracted into the air. And what we want to do is we want to adjust this prism so that the light in here in the prism is just horizontal. That's the condition for least deviation. So I'm adjusting the prism, and about right here is the condition where it looks like this light through the prism is horizontal. So now we're gonna put a point right here. We're gonna put another point right here, and then a point right here for the incident light, and then a point right here for the light coming into the air. And we'll also trace the prism. So now we'll draw this line for this light ray, and then we'll draw a line for this light ray, and we want these two lines to intersect. And in the figure for the prism, we come back to this figure for the prism. This angle right here is the angle of deviation, delta. And this is the vertex angle for the prism, alpha. So we need to measure both of these angles. So we'll use a protractor. Now we'll go to our data page, and for this angle of deviation, we got 28 degrees. This is also the alpha. And then now we need to measure this angle right here that the prism makes, the vertex angle. And for the vertex angle of this prism, we find 45 degrees. So right here we have 45 degrees for alpha, and then for the angle of deviation, this is 28 degrees. And now you can just plug in these angles in here, and you can figure out the index of refraction for this prism. So that's it for part G for this experiment.